Hello everybody and welcome back to another visual pattern challenge. Here is our pattern today, a little unusual. These are actually some diagrams of some molecules, some hydrocarbon molecules. We have in step one, we have methane. That's that kind of stinky gas that's given off when stuff decays. Here is ethane in step two, and here's propane in step three. Your challenge here today, and you could look at this as predicting the number of carbon atoms or the number of hydrogen atoms, but really what we want to predict is the number of bonds between atoms, and those bonds are represented by these lines. So your challenge is to predict the number of bonds in step four for whatever hydrocarbon molecule this is going to be in step four. If you can do that, can you predict the number of bonds in step 43? And can you write an equation that could be used to predict the number of bonds in any step at all? So that's the challenge. If you'd like to accept it, pause the video and give it a try. All right, so let's see. I'm just going to try to get a visual sense of what this molecule should look like and maybe just draw a model of it. Let's see. So we've got one carbon, then two, then three. So I'm guessing 4 carbons here, right? And they would have to be connected like they are. And then I guess hydrogen's off all the sides, right? So hydrogen here and here, but also one here. And then hydrogen here and here. And here and here. And here and here. And one off here. Okay, so now I think we can count the bonds along the horizontal. We've got 1, 2, 3, 4, 5. And then we've got 4 more though. That's 9, 10, 11, 12, 13. So it looks like 13 bonds in this molecule. And I think this actually is butane, which you might have in a lighter. Okay, so what did I say, 13? Yeah, 13. Well, it's maybe difficult to get a sense of how this pattern is growing until we actually look at the numbers. So let's go ahead and do that. So I'm going to make a chart with the number of steps and the number of bonds. So in step 1, that's 4 bonds. In step 2, we've got 1, 2, 3, 4, 5, 6, 7. In step 3, that's 4 and 6 is 10. And in step 4, we've got 13. When we take the difference between each step, 7 minus 4 is 3, 10 minus 7 is 3, 13 minus 10 is 3. Aha, we get a constant. So we can see that this is a linear rate of growth in this pattern. When you get that constant in the differences, it's linear. And we can use this equation for a line y equals mx plus b to model that. The m, the slope of your line, is going to be this rate of change, the increase in each step. So y equals 3x. And then the plus b, well, we can figure that out by trying it out with a step. So if we had y equals 3 times step 1, we're putting in 1 for the step number for x. 3 times 1 would be 3, and there are 4 here, so we would need 1 more. So I'm going to just put a plus 1 there and a plus 1 here, and that's what our b is. Although we should test this, make sure it's working. So let's try step 2. So y equals 3 times 2 plus 1. 6 plus 1 is 7. Yeah, that's how many in step 2. How about step 3? Y equals 3 times 3 plus 1. 9 plus 1 is 10. Yeah, this seems to be working. So it looks like our equation here is y equals 3x plus 1. This is the equation that tells you how many bonds there are in this kind of hydrocarbon according to the number of carbon atoms. You can think of the number of carbon atoms as the step number because it matches. So that's kind of cool. Now, whatever this complex molecule that has 43 carbons is called, I don't know, but we can figure out the number of chemical bonds in it. We can just plug in step 43 for x. So y equals 3 times step 43 plus 1. Let's see, 3 times 40 is 120, 3 times 3 is 9, so that's 129 plus 1, 130 bonds in that step 43 of these hydrocarbons. Well, how did that go for you? Did you get 13 for step 4 for butane? Did you find this equation? Let me know. Thanks, everybody.